Welcome to this other video. We are still on the tutorial questions. We want to find the determinants of these two matrices A and M by basically using the properties of a matrix as I previously mentioned, and also using Gauss reduction. Okay, so here we can see that the second column in this matrix A is proportional to 4, and the third column is also proportional to 5. So we can simplify this in the following way. So this can become 4 times 5, right? And we write it like this: 1, 2, 0, 3, 1, 1, 1, 1, and this is 0, 0, 1, 1, and here is 5, 6, 0, 6. Now, to find the determinant of this matrix, we start with this. The notation of determinant is this. I want to get rid of this value, right? 2 and 3, because we already have 0 here. That's very good. So we fix this first row. This is 1, 4, 0, 5. The second row will be R2 minus 2R1. So this and this is 0, and here is minus 1. Here we have 0, and the last one should be minus 4. Right, for the second one, the third row, we don't need to change anything because we already have 0 here. 1, 0. And the last one, we want R3 to be R3 minus 3 R1. So this is 0, minus 2, 1, and minus 9. All right. Now, for the next step, we want to get rid of this 1 and minus 2. So we have to fix the second row now. So first row is 1, 4, 0, 5. We have minus 0, minus 1, 0, minus 4. Given that we want this to be 0 by using the first row, so we say R3 become R3 plus R2. So if we sum up these two, we have 0, we have 0, we have 1, and we have minus 4. And the last one, we say R4 becomes R4 minus 2R2. So this is 0, 0, 1. So sorry, I forgot to put this coefficient here in front. So this should be 20, right? 4 times 5 is 20. So we have 20 here. So this is minus 1. And now we want to get rid of this term 1. So we have to fix the third row, but let's first write down the first row, second row. 1, 4, 0, 5, 0, minus 1, 0, minus 4, 0, 0, 1, minus 4. So to get rid of this one, we have to say R4 become R4 minus R3. Okay, so this is 0, 0, 0. This minus this is 3. All right, at this stage, we have an upper triangular matrix. So the determinant is just the product of the diagonal elements multiplied by the coefficient we have here in front. So this is 20 times 1 times minus 1 times 1 times 3. So it is minus 60. Okay, so this is the value of this determinant, the determinant of the matrix A here. Conclusion: determinant of A is equal minus 60. All right, let's look at this second example. So for this second example, we can see some similarities with the first example, okay? So you see the first row here is 14005 and here is 28010. So the first row here is multiplied by 2 to obtain the first row here. So similarities between A and M. Between A and M. So we, as I said, add 1 in M, so this is M. Matrix M is 2 times R1 in the matrix A. Okay, we also have some other similarities. We see that these two rows are swapped. R2 and R3 are swapped because we have 0 and 2, 4, 4, 5, 0, and 6, 0. So we say that R2 and R3 are swapped. Okay, R2 and R3 are swapped. So for the fourth row is the same. We have 3, 4, 5, 6, 3, 4, 5, 6. So they are similar. Now, this is all what we notice. If we rearrange this matrix, so this will be, we first say it's multiplied by 2, right? So matrix being multiplied by 2, or let's start with this. 2 rows are swapped. 2 rows being swapped means that we multiply by -1, right? Secondly, the first row is equal to times the second row. So this is times 2 times the matrix A. So basically, if I want to obtain the determinant of this matrix, using these similarities, I can just say that the determinant is equal -1 times 2 times the determinant of A. So basically here, what I want you to write is M, the determinant of M is equal -2, right, times the determinant of A. So knowing that the determinant of A is -60, so this is -2 times -60. This is 120. So this is very simple. So I can quickly give you another matrix. It wasn't part of this, but let me give you this matrix N. So if you consider this matrix N, and we want to find the determinant of this matrix, so we want to know the determinant of the matrix N. So I can check some similarities between N and A, and you see that the diagonal is the same. We have 1, 4, 5, 6. It's the same diagonal. But here we have 4, and the other side we have 2. So we see that M is just equal A transpose because all the non-diagonal matrix from the lower non-diagonal elements is the same as the upper in this matrix. So basically this is just a transpose. The matrix N here is just a transpose of matrix A. So the determinant of this is just a determinant of the transpose of the matrix A. And this is, determinant of A is -60. So the determinant of a transpose of a matrix is the same, right? So this is -60. So these are simple properties that you have to master well, so that every time when you have matrices like this, you can easily identify from one to simplify. We don't have to go through the calculations again. All right, this is all for this tutorial question. I hope you won't have any problem with the determinant anymore, because with the 3 examples we have solved so far, not only in this video, but even in the previous video, you should be able to find any type of determinant, okay? All right, thank you.